Hello again, physicists. Today, I'm bringing the truth when it comes to something called displacement. This is our first real topic of physics. What is displacement? By definition, it is the straight line distance between initial and final positions. The symbol for displacement will be the Greek letter delta followed by x. And the way we would read that is change in position. As we know probably from prior science classes, delta means change. So if we wanted to actually compute or calculate the displacement, what we would do is we would take our current position wherever we're located, and we would subtract our starting or original position from our current position. And that's what this over here is showing, that if we want to find our displacement or our change in position, we'll take our current position and we'll subtract from it our original position. Some things that are important that you need to know about displacement. First off, right off the bat, it can be positive, it can also be negative. Since we're talking about a change in a position, some movement, it's kind of like something that can be measured in meters. So our SI unit for displacement will be meters. And the last part, and this is very important, is the fact that the direction of your displacement must be specified. 20 meters in one direction is not necessarily the same thing as 20 meters in the other direction when it comes to displacement. Direction is so important when it comes to displacement that it's worthwhile to take a couple minutes and just think about the different ways in which we can refer to direction. There are going to be three significant ways in physics to talk about direction, and I'm going to go over each of them right here. The first one would be something you've done in math class before, and that's referring to direction in terms of Cartesian coordinates, or like a giant piece of graph paper. Where you have your positive x direction on your x-axis, you have the negative x direction, you have the positive y direction on your x-axis, and then you have the negative y direction. A second way to think about it are in terms of relative directions. These are things that we use in everyday life to refer to a position relative to us. Things can be up, they can be down, they can be to the left, or they can be to the right. Finally, sometimes we may even refer to directions in terms of cardinal directions, such as north, south, east, and west. Just know that really we can be talking about the same thing in a different way. It's kind of like tomato, tomato. For example, if something were to move in this direction, it's fair game to say that it's moving in the positive x direction. Or I could say that it is simply moving to the right. Or lastly, I could say that this thing is moving to the west. These are all equally valid ways of expressing direction. So here's a hypothetical example for you. Mr. H is at his house. Hello, here I am. Hello, students. And Mr. H is going to go for a walk. So we're going to consider Mr. H's house to be his starting position. Right? Now, Mr. H decides, because he's such a big nerd, that he's going to go to the new Star Wars premiere. So he goes for a walk on over here. And then he gets into the movie theater and he freaks out about how awesome these special effects are. All right, now this is my current position. All right, and let's say that in order to get to the movie theater, I had to go about 150 meters. All right, the big question is, what is my displacement? Well, to figure it out, I would have to determine what is my change in position, because that's how I find displacement. And we know it will be equal to my current position minus my starting position. All right. So in this case, we can say that, alrighty, well, my current position would be, I've gone 150 meters in the positive x direction. So that would mean that my current position is a positive 150 meters. And I'm going to subtract from that my starting position. Okay, in this case, my starting position is essentially 0 meters, where I started. And therefore, my displacement for this particular case would end up being a positive 150 meters. All right, and it's important to note that in this case, because I originated at my house, I decided that in my set of directions, in my little coordinate system, that right here, this is my origin, and everything is measured relative to this point. So if we were to take my little world here in our video and make it into some sort of giant piece of graph paper, you know, again, this would be the positive y direction, and then this would be the positive x direction. This would be the negative y direction. And this would be the negative x direction. And right there where my house is, that would be like my origin of 0, 0. This is called establishing a coordinate system, having an origin and some directions, and then all information of interest will be determined based off of that coordinate system. All right, so now let's say that Mr. H gets bored at his movie theater, and he decides to go get some ice cream down here. Yeah, I know, it's not the greatest ice cream restaurant, but just take my word for it. That is an ice cream shop. So he comes out of the movie theater, still talking about those great special effects, and he goes to the ice cream parlor, gets some ice cream. Okay. So let's say from the movie theater to the ice cream shop that is 50 meters. Here's the question, folks. What is my new displacement? I'll give you a minute to think about it. Very well. So if you said that my displacement was 200 meters, I'm sorry, but that is not correct. You need to look back at the definition for what displacement is. It is the straight line distance between where I start and where I finish. Therefore, if I wanted to draw out what my displacement is, it would be a straight line from the ice cream shop back to my home, or this right here. In fact, I could even represent this with a nice long arrow, like that. So this represents, again, what my real displacement was. And if you may notice here, this arrow is doing two things. It's pointing in the positive x direction, and it's also pointing in the negative y direction. Since during my travels, I not only traveled in the positive x direction, but I also traveled in the negative y direction. And to determine what my displacement will be, well, I'm going to have to somehow figure out what this arrow is as far as, you know, a change in position. I don't know if you can see it, but what we actually have here is a right triangle, because I have 150 meters here. This would be a leg of my right triangle. My 90-degree angle would be in here. The other leg of my right triangle would be the 50 meters, and then my total displacement would be the hypotenuse of that right triangle. So that means that, lo and behold, I can determine my displacement. I just got to do a little Pythagorean theorem. Told you we were going to use trig. So my displacement in this case will be my final position minus my initial position. Nothing's really changed about my initial position. It's still going to be 0 meters. But now I need to figure out, what is this point all the way the heck out here? Well, it's going to be 150 squared plus 50 squared. And then after adding that together by taking the square root, I would complete the Pythagorean theorem, and my current position would be approximately 158 meters. So therefore my displacement would be 158 minus 0, or 158 meters. So the moral of the story here is that you can move in 2 dimensions and you can still have a straight line displacement, but you need to account for each dimension you moved in. In this case, I moved not only in the x direction, but also in the y direction. And speaking of direction, how would I specify what my displacement was? There are a couple different ways I could do it. I could say that I moved in the positive x direction, and that I also moved in the negative y direction for a total of 158 meters. I could say that I moved in the southeast direction by 158 meters, or I could even say that I moved down and to the right by 158 meters to get my ice cream. All of these, again, are valid ways to express displacement. Okay, here's an example where even though I do travel, my displacement actually ends up being 0. So I have established another coordinate system where I'm saying that this is the positive y direction, this is the positive x direction, and where I am starting at right here is the origin. This would be like a position of 0 meters. So I can automatically say, therefore, that my initial or my original position will be right here, and it'll be 0 meters. And let's say that I go for a trip to the mailbox, which is 20 meters away. And I go on my trip, and then I get my mail and I come back. All right, well, what's my displacement? Well, my displacement, as before, would be the change in my position, and that would be my current position minus my original position. So that means my displacement will be, let's think about it. What is my current position after I come back from the mailbox? Well, I'm in the same place I started in. So that means that my current position is 0 meters. And my original position is 0 meters. So in this case, my displacement is 0 meters. In other words, I have 0 displacement, even though I actually traveled. I went somewhere. And this is the point to make, that there's a difference between what we call distance and what we call displacement. Because a lot of students like to confuse the two. They think that these are interchangeable. They are not. They are not equal at all. My distance traveled may have been 40 meters, the 20 out and the 20 back. But displacement, because of its definition, being that it's just the change in your overall position, it doesn't care about the path that you took. It doesn't care that you walked and came back to where you started. As far as displacement is concerned, you went 0 meters in this case. All right, so now the same scenario, but I'm going to go somewhere else. So I have the same coordinate system. I'm still starting at the origin of my coordinate system. But now Mr. H, it's a nice hot day. He wants to go cool off in his pool. So he goes for a walk and jumps into the pool. And that pool is located 20 meters away. So what would my displacement be in this case? My change in position, of course, will be equal to where I currently am minus where I started. Here's the twist. This is why direction is so important. My current position, in order to get there, I traveled this way. That is the negative x direction. Therefore, I have a position that is 20 meters, okay, and my original position was 0 meters. So my displacement in this case would be 20 meters. And if I did not include direction, this could get a little complicated because, well, which way did I go those 20 meters? For all I know, if I traveled 20 meters, maybe I went to my mailbox instead. And we must specify here, what direction did I travel those 20 meters in? And in this case, it would be the negative x direction. We could also say that I traveled 20 meters west. Or I could even say that I traveled 20 meters to the left. So again, this is why it's so important to make sure that you include direction with your displacement, because without it, you will not be specific enough. And then no one will know what direction you went in. So with that said, physicists, we've done a lot here. In class, we'll go over this a little bit more, and we'll even talk about graphical interpretation with displacement. So till next time.